welcome on our second last day at the K-Show. Has been a very busy and fruitful event so far. So on the second last day, I'm happy to announce a different business unit from Milliken, besides the plastics business. Milliken is also strongly represented in the polyurethane industry, so I'm happy we can have this unit represented as well. Today we're going to have a talk about the stabilization of polyols with our additives, presented by Herbert De Breuck. Herbert is our global TSND leader for polyurethane based in Ghent. He is responsible for TSND and R&D in this area. He has a long track record in industry. He started in the late 90s at Bayer, Macrolon business, moved then into the polyurethane business with Recticel, rigid foam. After that went into development of medical and technical textiles at Luxilon. And in 2019 he joined Milliken in a role as a European TSND leader, and pretty quickly he moved into a global role. So please join me in welcoming Herbert. The floor is yours.
Thank you. Thank you very much for this nice introduction, Dan. So, I think a lot of you are familiar with Milliken. For those who don't are familiar with Milliken, we are a global player. Our headquarters are based in South Carolina, in Spartanburg. But nevertheless, we have more than 70 locations worldwide, so across 15 countries. In Europe, for example, in Belgium and in the UK. In total, we are more than 7,000 associates, and we are creating more than 10,000, 11,000 products in the meantime. And everywhere you touch a Milliken product, it can go from agriculture, apparel, the floor you're walking on, the carpets, the detergents you're using are colored with Milliken, the PU mattress is stabilized with our antioxidant, so a lot of applications that are using our products where you're really not aware that you're touching a Milliken product. Milliken is also a responsible company. So in our slogan we strive to make a positive impact for generations to come. And that's really what we do. For example, we are listed as one of the most ethical companies in the world. We also have our sustainable targets, which we measure and which are monitored. We are an EcoVadis Gold, so that places us in the top 2% of companies globally. We support also the United Nations Global Compact, and we are calling for action to save our planet and be sustainable. And we are also driving the CDP, so that means we are looking how we are doing on greenhouse emissions, how we are doing on water security. So we are a quite responsible company, and we are proud of that, and we are all working very hard together to achieve those goals. Coming back to the talk of today, I'm going to talk about an antioxidant. Antioxidants are added in polyurethane to stabilize polyol, to stabilize foams. And if you give a brief history of where this development comes from, originally the antioxidants were developed just to stabilize the polyol. So in fact, to avoid fire, to avoid that your plant burned down. That was the original stake of antioxidants. But over time, there were more and more demands for improving the foam properties. And by an antioxidant, you can, for example, avoid a scorch. You see the scorches. So that yellow or that brownish discoloration in a foam is caused by oxidation. Also, foam is really touched by NOx, so fumes from forklifts or cars or whatever in the area, exhaust from heating, central heating, can cause discoloration of foam. Another influence is the light stability. So foam can discolor by the influence of UVA radiation. On top of that, and over time, there were stronger regulations for emissions, for example, automotive industry, also bedding, so VOC, fogging, odor, the smell of polyurethane foam. So there were requirements on how can we reduce this, and antioxidant is a very good way to reduce VOC, because you avoid the oxidation, you avoid degradation products, which creates then, of course, a lower contribution to the VOC and the fogging. But last, and that is really where we're going to talk about today, is the regulatory and the health and safety. So we see a lot of shift in the last years to a more stringent regulation. And one of the regulations that is changing is the use of diphenylamine as an antioxidant. A little bit of chemistry, back to the basics of our product. For those not familiar with the polyurethane products, we are reactive products. We have reactive chemistry. That means we have an active center. In this case, it's an antioxidant. For our colors, we have a chromophore. It's different. We have a polymeric tail on it. Why we use this polymeric tail? To make it liquid, to make it easy to handle, that we can mix it with the polyol, and that it's compatible with the polyol. And on top of that, we add a functional reactive group. In this case, it's a hydroxyl, which will bond with NCO, that is a cyanate, and as such will not contribute to the emissions. And that's really what is our secret. It's bonding really in the polyurethane matrix. What is making our technology new and novel and different than our competitors is that we are interfering in the first step of the radicalization. So a little bit a difficult scheme, but you have a polymer, which is our polyurethane. And the first thing, what you have in polyurethane is an exotherm. So it's a reaction that creates heat. Can really be big, 160 degrees is not the exception. So what happens then? There is a formation of a free radical, a carbon-centered radical. So the carbon gets radicalized first. And our AOX is interfering really in that first step of the oxidation cycle. The other really good antioxidants, conventional antioxidants, inert phenols, aromatic amines, phosphides, are interfering in the second step. What is the second step? Is that the oxygen, together with the temperature, creates a lot of different radicals. So allyl radicals, peroxides, so a lot of radicals that are formed. And those products really interfere in the second step. That means that our product is really an early defense in the oxidation of a polyurethane foam. In reality, what polyol suppliers and foamers as stabilization package will use is a combination of both. So they will use as well a package with an early stage antioxidant combined with a conventional antioxidant. So what is our approach now? We have two approaches. We have a downstream approach and an upstream approach. So what means the upstream approach? That is really at the polyol manufacturer. So the polyol manufacturer always adds an antioxidant in his polyol. And we offer either a ready blend, so that's a blend and milk mix, it's an inert phenol combined with our AOX, or we supply the Milliguard AOX-1, which then can combine with an inert phenol that they have from themselves. Often is that Erganox 1076. This creates, of course, then a full versatile approach. That means that the customer can really tailor his polyol depending on his needs. And then he can optimize his loading depending if he needs a really low VOC package or he needs a really anti-scorch package. He can really combine and make his own polyol stabilization package. Downstream, that's what we call a booster. So that is, for example, when a foam really needs to be very wide. For example, a bra foam, automotive foam, head sealing, or he needs a really good VDA compliant, so low VOC product. So these are really the two areas we're working on. And I'm going to talk later on more about the polyol upstream part. So the first thing we do in the lab is check the performance in the lab. We have a special technology for it. It's called microwave scorch. So what we do is we make a foam, but of course in the lab your foam is small, cools faster down. You don't have really the energy to create a scorch. So we developed a method which is called microwave scorch. So we, in a controlled condition, we heat really the foam to create scorch. So in fact, we stimulate to make bad foam. So when we come to the industrial standard, which is a diphenylamine-free diphenylamine product, then you see that it's quite yellow. It's already yellowish from its own. So what we then is we make Milliguard AOX blend. So that's when we made self with AOX-1 plus 1076. And we compared it also with diphenylamine-free solutions that are on the market from colleagues. And then we saw that we are performing quite well. You see our foam is much whiter, less scorch than our colleagues. And even at lower ppms, 4,000 compared to 5,000, you see that our AOX blend is already much better performing than our colleagues with alternative amine-free products on the market. So what we did after the lab was those were very encouraging results. What we did, we moved to a company in Spain, which is called Jack Flex. And Jack Flex made really big bunts because, yeah, okay, a lab test is nice, but you really need to prove it in industrial conditions. So what we did here is we really pushed the foam to the limits. So normally in PU foam, water is a blowing agent, and you use it at a level 4 or 5 PHP, parts per 100 polyol. You use the water to raise the foam, and you have an exotherm around 170 degrees in this case. What we did, we add extra water. We had 6 to 7 parts water, and we really pushed up to 190, 200 degrees, so close to, yeah, really breaking down the foam to prove really the scorch performance of our antioxidant. And what we found then is that the AOX blends we made, so this is a ready blend we made, this is a blend we made with 1076, and the alternative amine-free antioxidant, then we show that we are really better compared to the available colleagues on the market. So even at lower concentration, our package was performing better than our colleagues. Another thing that was really interesting was to see, you see the exotherm of the foam. And then you see that the green, which is our colleagues, have a longer exotherm, so that means they have more chance to create degradation products compared to our. Our product really starts cooling down faster, so it's lower in temperature and cools down faster. So that means we create less scorch. As I mentioned also, the VOC, we are VOC compliant, so the VDA 278 compliant. And you see here the results that were made in a microchamber test in RMC, in our headquarters in the US. And you see, for example, that the reduction of ppm from the total VOC is going down from 69 to 22. So same for the fogging, where we really reduced completely. So effectively, at low loadings, plus the reaction that we do with the isocyanate creates a really stable package and results in a low VOC and fogging. Same with EUV. You see here the yellowness index. The yellowness index is the measurement of how your foam discolors, how yellow it gets. And you see that the industry standard, which is the diphenylamine-free containing material, is much higher in yellow index compared to our minimum stabilized plus Milliguard AOX blend over time and after UV exposure. We got a similar result for NOx, which we measure in a gas chamber in our lab in Ghent, where we expose it to NOx, and then we see that also the yellowness index there reduces significantly when you have a package with AOX compared to our other antioxidants. What, as a conclusion, is that, of course, we have now this changing regulation in diphenylamine-free packages that are going into the market. We offer a very good polyol and foam protection compared to an industry standard and amine-free alternatives. We are quite effective at low loadings. So maybe I forgot to mention the loading of the antioxidant in the package is around 400 ppm of AOX. And we have a significant reduced scorch. We have good NOx and UV stability. We are compliant with the most of the VDA 278 standards. And of course, we also, and that's the important part, we are compliant with the newest regulatory requirements on the market. Voila, that's a little bit the summary of our new development in antioxidants.
Thanks, Herbert, for the exciting talk you brought to us. So I think a remark I want to make is it's exciting to see how your team was able to bring some innovation in polyol stabilization. That's typically an area where you don't see a lot of things moving. So I think that is very exciting. Can you comment on where we are today with that technology in the market?
Yes. So today we have already, first of all, it's quite new. We won a couple of prizes with this, innovation prizes, also at Europur, the European Association for Polyurethanes. And what we see in the market is now that several polyol suppliers are using our antioxidants already as part of their polyol package. especially for more demanding polyols. Polyols with, we really have a low VOC, as I mentioned, who are, really need a very low scorch. There you see specialty polyols really already using our Antiox package. Also renewable and recycled polyols, stabilization of recyclable. Even PU is starting to recycle and be sustainable now. So there also our antioxidants are used. Then definitely in really critical applications as a booster. So that's also something that is more and more successful. People see the benefit of, and of course they have to replace the diphenylamine because that's coming up as a new regulatory.
Yeah. Thank you, because on one hand, chemistry and technology is exciting, but in the end you want to solve a problem and see it commercialized, and that's exactly what's happening. So thanks for that comment. Maybe I have a last one for you, Herbert.
Okay.
So you talk about the specialty polyols, the automotive. That is basically not new in industry. What is happening now in industry is the regulatory change on the amine-free needs for stabilization. Can you share your view how that is going to evolve over the coming years?
Well, yeah, that was diphenylamine-free is a very good. Diphenylamine is a very good antioxidant. So it's a workhorse of the industry, but there's a regulatory drive on health and security. So it is now considered as a product with a risk of reproductivity. So people, polyol suppliers are getting aware, foamers are getting aware, but also the customers are getting aware. So the customers really ask now more safer product, more stable products, and that's why there is a push from that side also to change the package and go really diphenylamine free. And AOX is one of the candidates to do that.
Okay. Can you give Herbert a final applause for his effort?
Thank you.